Good morning, good afternoon, good evening, wherever it is you are joining us. Welcome to another session of the Niger Data Platform. Today's topic is Manage Experiment Compute Contexts. This belongs to the Azure Data Science track, right? And your host here or presenter today is Paul Barnabas. I'm a Microsoft certified trainer, data and AI evangelist, an IT consultant, trainer, and speaker. I currently lead the data management and business intelligence team at 7up Bottling Company. We have some partners who are sponsoring these sessions: Microsoft, Jira Computer Solution Enterprises, and Enterprise DNA. So, going to the context of today's class, it's manage, experiment, compute context, and to further break down that theme, it's critical that we understand what experiments are. So, essentially, experiments are executable processes that run once or multiple times. These are is an event that essentially depicts how an activity should be run. For example, I want to be able to connect to a source, pull in some data, clean up that data, do some exploratory data analysis on the data, and produce an output. The whole process that essentially does the extraction, does the cleaning, does the output, can be referred to as an experiment. And typically in an experiment, metrics are essentially generated. We have output files, and the metadata or events essentially, can be recorded in the log files. So this can help us go do some further forensic, analysis on the experiment to see the time it took, what were the outputs, what were the challenges, did it fail, so all of these can essentially be achieved. And this is an example of an experiment. So we are seeing here some packages are being called in, right, from the Azure Machine Learning Core, and this is coming from Python, right? We are identifying the workspace, so we'll discuss what a workspace looks like in the Azure Machine Learning environment or studio. Right, so we're either creating or we are getting an existing workspace. We're initializing the experiment, right, and we are essentially starting the log. Then we are reading data, right, from the CSV file, counting, the number of rows in that data set. The logs are being observed and they are being currently also logged. Observations are being logged, right, as observations. We have 100 records, right, out of that data set being extracted to a CSV file, and then it's outputted into a folder. And this essentially completes the run of that experiment. So to demo how to run an experiment, simply go to ml.azure.com and create an account, log in, and you might need to have a subscription. If you're able to get a student subscription or whatever subscription available to you, you can go ahead and create a resource group, and then you would attach a workspace to that resource group. For this demo, I already have a workspace created. It's called ML-workspace. I can easily go into that workspace, and then I see the different features available within the studio. Right, at the moment, I will simply go to notebooks. This is where I have a Python file created for this demo. Right, it's called training demo. Right, I'm going to launch the file. Just going to try and refresh it so that it loads properly. Right, something very important to note is that within this file, as I launched it, I am making use of a particular instance, right, I'm also making use of an environment. All this will be explained within the context of today's training. But to demonstrate how an experiment runs, I would simply run this set of scripts. So based on the example, I'm able to import this workspace experiment, right, an environment, also pandas as a package for Python, right? So I'm going to run this. I've been able to import them, and the next block of code also essentially depicts me being able to initialize or get my workspace. I launch the experiment. I also go ahead and connect to a data source called data.csv. I do a count. I log, right, the experiment. Then I'm also able to extract about 100 records from that data set into a CSV file. Right, so let's run that and see the output of that experiment. Okay, so it's telling us that the experiment has started, right? It's currently being run, okay, and that is complete. By the time I refresh also on the left hand side, I now see I have a new folder created, and within that folder, I have within that folder the sample.csv file. Okay, so let's go ahead and check the details of the experiment. Remember that the concept of our experiment is during the process when it's running, right? We are able to get metrics, we're able to get some insight as regards the activity of that experiment. So I'm going to click on job details, right? And within this details of the job, I'm able to see it ran successfully, right? It took about 8.52 seconds, right? I can go to the metrics pane. I can see, right, 607 rows. Those are the observations within that data set, right? I can check the output, right? I see it created a new folder called outputs, and then the file called samples.csv, and within this file, I can see all of the columns within that data set, and I can see I have just only 100 rows as an extract, which is what we wanted. I can also go ahead and review the code that was responsible for this job, right? So this essentially gives me a complete overview of an experiment. So let's go back to our slide. So we're going to talk about environments. So as I was explaining, I said that there are two things involved, essentially necessitating the smooth run of the experiment, which is the availability of an environment, and then also a compute target or a compute context. So what are environments? So environments essentially is, just as the term says, right, is where um, um, it's like an operating system where the files or the experiments we want to run will reside on, right? It can be in a container, it can be within a target, it can be on your local machine. Essentially, within this environment, we have packages of either Python or R or whatever language we want to try and coding. It's installed, right? So essentially, as we can see within this diagram, right, I have this environment defined. If the environment can sit on its own, right, either on your local machine or within an environment, or it can sit within a Docker container, so it can be containerized. I simply, maybe on Kubernetes or on Docker itself, I have a container that contains the environment I need, and right, I have that also sitting within a compute context or target. So that's how, or the context around environments. So how do I go about creating an environment? So basically, with the use of a YAML file, right, which contains the standards, right, of that particular environment. I can define it and then just call it up, right? Define it as a variable env, right? State the name of the environment and then put in the attributes of what I want, maybe packages I want within that environment. I can state it in my YAML file and then connect it to it or point it to that direction of the file. I can also just define it and say, okay, fine, the conda environment should be Python 3.6, right? And the environment is a training environment. I can also do something by specifically identifying the dependencies. That's the packages. For example, now Python packages I want to be, included within that environment that I can explicitly state. This just gives us an overview of how to configure an environment, right? Within a container. So I told about the concept of either in isolation or within a container. So here we are using Docker, right? And within the config file, we've specified the attributes or the things we want to be made available within that environment. This is another example. To be fine, I'm referencing an image existing in the Azure Container Registry, right? So I'm pointing to that image, right? And within that image, I have the list of the packages or the items or the specifications or the configurations I need within that environment. This is one to create a Docker file. So, you can also create a Docker environment or a Docker image from a Docker file, right? So you put the specification within your Docker file, and then when you run it, it's spin up an image which contains the environment and the attributes of the environment, right? So let's go on to the next slide. So this is essentially how to register, right, or reuse an environment. So we're going to do a demo on this whereby we can see the list of environments we have within a particular compute instance or within a workspace, right? So let's go ahead to the demo session, right, and see how we are able to generate that. So I'm going back to my Azure Machine Learning Studio. So I'm going to go back to my notes. So within my training demo, I have a small script here that I can use to essentially, generate the list of environments that I have. So we'll look at this from the concept of a script, and we'll also see how to view it, physically within the studio. Right, so what I'm doing here is just importing the environments as a variable, as a package, from the azureml.core. I'm referencing my workspace, right? And the next thing I'm going to do is just loop through, right, and extract all the list of environments that I have within my ml-workspace, workspace. Okay, so I'm going to run this. Okay, and as we can see, so let me manage my space here. So as you can see, I have a list of all of the environments within this workspace, right? So it gives me the details about these things. So this is one way to go about viewing the environments. Another way of achieving this is you expand on the pane and right and locate environments. So when you click on environments, so here you can see the list of environments. So this is almost similar. It's exactly what was displayed, right? So for example, I can click on this and then it shows me, right, the name, how it was created, the operating system, right? And then within it also, I can see what makes up my Docker file. So within this Docker file, I can see all the different packages that I'm calling or including within, the environment. So this is essentially how, you can check right? Or check the existing environment within a workspace. You can also go ahead, right, and with scripts to go ahead and define environments, right? Environments can be created also. So if I want to go ahead and create a new environment, I'll simply go and select create environment, put in the name of the environment, put in a description, select it if it's from an existing environment, so I can decide to make use of an existing Docker image or upload a Docker context, right? Or just even define a new context essentially, right? So let's do test environment. So I okay, so let me make this underscore. Right, so within my Docker file I can now specify all of the different packages I want to be included. Once that is done, I can include a tag, review it, and create it. And just like that, based off an Ubuntu image, including the package I need, I've been able to set up an environment. Okay, so we're going back to our slide. So we now want to talk about compute targets or compute context, right? So what does this mean? What does this essentially mean? So we've talked about experiment as a script, as an automated file that helps us run processes once or multiple times. Those scripts would sit within an environment which is like an operating system. Now, these cannot run without a computer. So a compute target, right, is more like it's an environment. It's like a computer, right, that essentially has a storage. It has either a CPU or a GPU, right, and it's simply within this compute context that we're able to specify our environment and run our experiments, right? So within Azure Machine Learning Studio, we have different types of compute context. We have the local compute, we have the compute clusters, and we have the attached compute, right? For the local compute, this is really just a workstation within the Azure Machine Learning instance. So there they configure, you can select the hard disk, you can select, the GPU, all this you can select, and then it spins off, a simple box for you that you can turn off, you can turn on, right? And there's also the compute cluster, right? So this is more like a cloud-based cluster managed in Azure Machine Learning Workspace. So this you can start, you can stop, you can scale up, you can scale down. So based on your workload. So this is a combination of clusters that you can use on like just having one compute context, right? And the third one is attached compute. So you can have, for example, a virtual machine, in one environment, and you want to run your experiments within that environment. You can simply attach it to your Azure Machine Learning environment or studio, right? And then run your experiments within that environment. So it can be, a virtual machine sitting in Azure in any environment. It can be Azure Databricks. It can be Azure AD Insights, right? So you can do all of this. So how do I essentially create a compute cluster? Right, so we'll be doing two demos of this. We'll demo it using the script, right, and we'll also demo it using the studio itself, right? So what we are seeing in this script is we are importing the compute target and the AML compute. We are specifying the name of that compute that we want to create, right? And then also the configuration. So in terms of the VM size, there are different types of SKUs, right? SKUs available. You can select the ones that is preferable to you, right? You can select the number of nodes and also set the priority on the virtual machine, right? So with this, I'm able to now create that compute, right, and then show if it's actually completed. So this is essentially how to do it the script way. We would also see how it's done using the graphic user interface, right? So this is using, so maybe I want to run a particular experiment, right? So I can decide in the configuration of the experiment to leverage on a particular compute target or compute context that I've created, right? So this script simply just states it. So this is just identifying the source of my directory and the script, and then identifying the name of that particular compute target that we want to use to run the experiment. Okay, so let's go on a demo session and see how this is done. So I go back to my home and let me identify where I have the scripts. Okay, so this is the script to create a compute cluster, right? So I'd already explained this, so we are going to, the name of the compute is supposed to be AML-cluster. So I'm going to run this script and let's wait and see how it essentially creates that compute target for us. Okay, okay. So I am seeing it's showing the output. It said succeeded provisioning operation finished, which was successful. So at the moment, let's go ahead and see the compute details. So it's currently spinning that up because based on the configurations that we fed in, right, it's going to create a virtual machine based on the specification, right? So where specification, the selection was a standard DS11, right? So with a 2 core, 14 gig RAM and 28 gig disk. So this is going to take a while, so in the interim when that is running, let's go and see how we can run this using the graphic user interface. So expanding the navigation pane, you can simply scroll down to compute. So remember that I was explaining the different types of compute targets. So we have the compute instance, the compute clusters, the attached compute, right? The inference clusters also is available as a new offering. So this is an integration with Azure Kubernetes, right? Where you can now run large, compute instances, right? So we already demoed how to create a compute cluster, right, which is currently being created. So let's see how we can create a compute instance. So I'll click on the plus sign to create a new compute instance. So okay, so let me call this Niger compute instance. So the location is West Europe. So we have the option, of selecting either a CPU or a GPU. So a CPU means a central processing unit or a graphic processing unit, right? So you can decide to select either one of these, and as you select them, it shows you the skills available. So I would stick to using a CPU, right? And we can see the list available. So I'm just going to choose this bare minimum, right? This 2 core 14 gig RAM, 28 gig storage, right? So I select that one, and so you can also check out the advanced settings if you would require to probably use SSH, or set up any other thing, right? So once that has been selected, it's just to click create. And also within a few minutes you would have your compute instance fully functional. So let's go back and check. So our compute cluster has essentially been created, right? So I'll click into it and see the details. So it's successfully created, right? We can see these are all the details. So we can specify if any node is currently being used, it's listed here. Okay, so that essentially depicts how to create a a compute cluster, right? So for our demo session, right, when we were running the experiment, we're making use of a compute instance that was initially created. So take note that we were making use of a notebook, right, within this Azure Machine Learning Studio. But there are other different applications that we can leverage on, right? That we can use, to run experiments. So you can decide to make use of the one that is more familiar, that you are more familiar with. So if you're someone who likes to use Jupyter, you can leverage on the Jupyter application, right? It simply connects also to your local hosts, right? I mean within the Azure Machine Learning Studio. So when we're looking at the folder, right, we saw an ML machine learning folder, right? And then I can click and launch also my Jupyter notebook, right? And or go on to other folders. For example, I check this out, I click on this notebook, and then I'm also able to run it. So this is still running within that compute cluster, right? I can monitor the performance, the memory, I can see the usage of the CPU, right? And I can run all of these codes. I can run them and see essentially, how they are doing. So this essentially, is the process of being able to create a compute target within Azure Machine Learning Studio, leverage on an environment of choice, right, and run your experiment within the, run the experiment within the environment that sits within that compute context, right? So this essentially serves as the workflow. I will take us back to the slide. We can also leverage on these resources, right? Check out more information about what I've just talked about, right, via these resources. So on Microsoft Learn, there's a documentation also around Azure Machine Learning, right? For the environment, there's another one also, for compute targets, and then also around performing data science with Azure Databricks. So thank you very much for joining me in this session. It's a pleasure having you. And if you have any questions, you can always drop them in the search box or in the question box below this video, and we'll take time to ensure we answer them. Thank you very much.